So hi everyone, I'm Sean and I'm the Senior Developer Advocate for the UK and Ireland at AWS. And I don't know about you, but I've seen a lot of slide text over the last couple of years. So today I'm just going to talk just between you and I, to make it a bit more personal. So as a developer advocate, I spend a lot of time writing content and building demos to show off all the super cool stuff we build here for you at AWS. And with that in mind, whenever I put together a workshop or product, I like to include just a little bit of magic, just making things work as seamlessly or invisibly as possible so developers such as yourself can just enjoy what you're building rather than spending time fighting with bugs or struggling to figure out instructions. And this year at reInvent, which is our premier learning conference that we run for the global cloud computing community, I was involved in writing a workshop about migrations, getting your stack from wherever it is now up to AWS. And that would seem like a fairly straightforward proposition, right? Take thing in place A and put it in place B. Well, no. Anyone who's ever worked on a large scale migration will tell you that it takes a whole bunch of planning, testing, and coordination to get something from place A to place B. And no two strategies are the same. There's an almost incalculable number of AWS services and combinations of them that you can use to deploy your applications to. So, how, when you're running these workshops, do you cover all the different use cases for as many people as possible without writing dozens or hundreds of specific niche workshops? Well, with a little bit of Go-powered magic, of course. See, first of all, when we were thinking about putting this workshop together, we needed a demo application that people could migrate from place A to place B. And we didn't want people to have to deal with example applications that would require installing dependencies and having to keep tracks of files across multiple locations. So things like Node.js with its Node modules or Python with pip, they're out. That's not part of the migration. That's a detail of the language. So having a single compiled binary was perfect for us. So Go was a very early, obvious choice. That said, having a server be a compiled binary doesn't completely help solve that if we have to deliver a directory of static assets that we want to serve through the application. So we wanted to build a HTTP server to demonstrate these things. So we just want one file, one application that has it all. So how do we achieve that? Well, there's this great module called go-bin data, which can take a directory and recursively convert the files therein to byte slices. And that means that all of our static assets are now built into the compile binary, and we can serve them from memory when the app is deployed. And so that's that. One tiny little magic app that you can pick up and deploy without having to worry about assets. But here's the rub. I mentioned we have a bunch of services that you can deploy applications to, and we planned to cover more than a couple of them in our workshop. You see, each service has its nuance and specificalities when it comes to running an application. So what works for one service out of the box may not work for the rest. Think Lambda versus EC2. It's a whole different mindset. And we're going to need an app that can detect where it is and behave appropriately instead of just firing up and hoping that it'll work. Now, it's easy enough to build something that goes, ta-da, you deployed me, well done you, woo! But that feels like a missed opportunity. We wanted to build something that would only tell you not only tell you that you've done something right, but it would give you more information about what you had done. So how do we go about that? How do we build one app to rule them all and not immediately fall over when we hit an edge case? Well, that takes a little doing, but we figured it out. See, some services in AWS are kind enough to tell you when you're executing in their environment. Take Lambda and Fargate with ECS, for example. They set environment variables that you can look up and use to change things accordingly. Other services, however, like EC2, are a little bit trickier. See, EC2 doesn't set such an environment variable, but it does have the metadata service. And so the metadata service is an API which exists on your EC2 instances that you can query to find out information about the instance that you're running on. Things like instance name, public IP address, the AMI ID that was used to launch the instance. And so that's what we decided to do. First of all, we would check the environment variables to see if there were any services that we would recognize. If not, we then check for the presence of the metadata service by making a quick HTTP request. If the metadata service was there, we then do a follow-up request to get the instance type and check it was a valid value rather than risk delivering a false positive to our users. So with environment variables and the metadata service, we've managed to cover our serverless platform, some of our container platforms, and EC2. And that's not everything, but it's a fairly big coverage of all the options we have to offer. But let's talk about Lambda. So you see, so far, our little magic application is a self-contained HTTP server, which, while very cool, isn't exactly the best thing to be serving up in a Lambda function. Lambda functions only run for the time that they're needed. So having an always-on, always-listening server makes no sense. So how do we get this thing to serve all the other use cases, but also feel at home in a serverless environment without bringing a load of bloat with it? And that's obvious, right? We make it create a new version of itself, specifically for Lambda. That's right, our app can make a new version of itself prepared specifically for serverless environments. So how does that work? Well, if you think back, everything we need, all we need to do now is rearrange it. So if our workshop attendees hit the Lambda section of our Magic App webpage, we take all those dynamically generated views and render them for hosting from a secure S3 bucket. Then our code writes a new version of itself, which admittedly is in JavaScript. Sorry, everybody. That will let Lambda serve the data from the S3 bucket out through an API gateway endpoint. And this all then gets put together in a zip archive, which is dynamically created and then sent as an octet stream to the requester. And all that can be done with just the click of a mouse. And that's it. That's how you build a magic app that knows where it is in AWS, changes how it acts depending on where it is, and even creates a new version of itself if it needs to. All in one handy, Go compiled executable package. I've been Sean Tracey. Thank you for your time.